Hi, good morning. So today I'm going to discuss today's LeetCode daily challenge problem. Problem is that case smallest prime fraction. Okay. So what is the problem statement is that you are given a sorted integer array containing one and prime numbers where all the integers are unique. You are also given an integer k. Okay. One and all prime numbers like 1, 2, 3, 5, 7. Dot 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 like, and will be given on 1k for every I and j where I less than j. We consider the fraction array I by array j. Return the case smallest fraction considered. Return your answer as an array of integers of size 2. Where answer 0 will be the array of I and answer 1 will be array of j. Like numerator and ये denominator. Okay. So one observation is that fraction will be always value will be 0 to 1. Why? Because they have mentioned that I less than j. Now array I by array j. So on the right side, j is on the right side of I. So right side it will be always greater than array j, always will be greater than array of I. Why not greater than equal to now? What? Why? Because each value is unique. Unique value are given. Okay, here it is mentioned that all values are unique. So it's not cannot be possible that two are repeating or three are repeated. Okay. Now, for this example, let's see how it is going on. So 1, 2, 3, 5. So k is equal to 3. So what are those fractions possible? Like 1 by 2, 1 by 3, 1 by 5, 2 by 3, 2 by 5, 3 by 5. Got it right? So here I have to get the third smallest fraction. Right? So first smallest is 1 by 5. This is the first smallest. Then is 1 by 3, then 2 by 5, then 1 by 2, then 3 by 5, then 2 by 3. So here first, second, third, fourth, fifth, sixth. So answer will be 2 by 5. So I have to mention written 2 is 2 and 5 as a, this is the answer, right? So 2 and 5, got it right? 2 is the numerator and 5 is the denominator. Got it right? So here if I use priority queue like here also I have find out like here all are those possible fraction and I have to find out the case smallest. So if I store all these fraction in a priority queue, okay, and I pop k times, so or k minus 1 times, okay, suppose k minus 1 times I pop from the priority queue, then the top element remaining in the priority queue will be the k smallest fraction. Got it right? Like if I store suppose 10 elements, so this is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So I have to find out fifth smallest. So this is the minimum heap or minimum priority queue. Okay, mean heap. Now I pop 4 times k minus 1. So first it will pop 2, then it will pop 2, first it will pop 1, then 2, then 3, then 4. 4 times. Then the remaining elements in the priority queue is the top is 5. So this is our answer. This is our fifth smallest fraction or element. Got it right? And here I and also I will not explore all the possible fraction. Why not? Because if I create all the fraction of a number right here, if n elements are present in the array, so number of fraction will be n into n minus 1 by 2. Why n into n minus 1 by 2? Because let's see, like for there is 5 element 1, 2, 3, 4, 5. So for this index 0, what are those maximum possible fraction? 1, 2, 3, 4. So For 0 I have 4 option, 4 fraction. For this 1 I have 3 option, because I have to always take the right side. Denominator always will be the right side. J will be greater than I. So now for this option is 3. Here option is 2. Here it is 1, and here it is 0. Right. So what is the sum of this 1 plus 2 plus 3 plus 4? Which is, you can like check that this is 4 into 4 plus 1 by 2. So this is 10. Got it, right? So this is actually n is 5. So 5 into 5 minus 1 into 4 by 2. This is also 10. Got it, right? Y n into n minus 1 by 2. So here it will almost the time will be big of n square, and also space will be exhausted if I export all the fraction at the beginning. So first I will insert all the smallest fraction into the priority queue. Okay, then I will pop one and create the next smallest fraction of that, which is starting from the, or whose numerator is current numerator. Okay, let's see the code. It will be easy, like here. So I have created a parity queue whose first value is a fraction value, because I have to get the value with respect to the fraction, and also one extra pair because I have to create the numerator and denominator. Okay, and now I push all the smallest fraction. What is the smallest? If I like array of I with all the possible with array of n minus 1, because array of n minus is the always the maximum element, so all the left element will be smaller. So that's why I am pushing the value as array I by array of back, means array of n minus 1, and the numerator value really is I, and the denominator value is array of n minus 1. Got it, right? And why I am multiplying with minus 1? Because suppose the fraction value is, because by default the parity key is max heap, and if I use it as a mean heap, then what I have to do, like max 10 is the value and 9. So if I multiply with minus 1, like minus 10 and minus 9, so in max heap what will come first? Minus 9 it will come first. So this is the same way, like I will get this if I don't want to use mean heap directly, right? So I am multiplying, that's why I am multiplying with minus 1. Now I am traversing k times. Okay, so k minus 1 times I will pop from the priority queue. That's why I subtracted with minus. Okay, minus 1. Now I pop from the priority queue. Okay, and what is the current? Like current second, like first it will insert 0 comma n minus 1, then 1 comma n minus 1, then 2 comma n minus 1, then 3 comma n minus 1. Right, in this way I will push all the thing. Now I will push, like first it will pop 0 comma n minus 1, because this will be the always smallest. So next smallest will be depend on the this also, like, so I will insert 0 comma n minus 2, this combination, because array of n minus 2 will be like array of I by array of n minus 2 will be always like greater than array of I by array of I plus 1, right? That's why I am taking from the right side, I will shift 1 left. So that's why current second minus 1 is, so this is the n minus 2 currently denominator, and again push into the priority queue. Okay, minus 1, same current first, this will be the 0, and current second is currently n minus 2, yes, and push into the, and also store the numerator and denominator in, and push into the priority queue. In this way I will export the k minus 1 times, and at the end I will, the top of the priority queue will be the our answer kth smallest. So that time I will return the answer from result dot first. This will store the numerator, and result the second it will store the denominator. Got it, right? In this way, how priority queue it will be easy. Okay, let's see one example on another approach where I can use binary search. Okay, so like what is the maximum value? I have explained that array of I by array of j, maximum value is 0 greater than equals to or less than 1, right? Why less than 1? I mentioned that this value cannot be repeated, that's why it cannot be 1. And why 0 to 1? Because I is less than j, and this is mentioned, this is sorted array, so array of I will be always less than array of j. Got it, right? So first our left pointer will be at 0 and right pointer will be at 1. Okay, so suppose in I will check that mid fraction is 0.65. So I will check how many numbers are smaller than how many fraction are smaller than 0.65. If this the number of fraction is equals to k, then we can always get the like last numerator and denominator, right? And also return that. And otherwise, suppose here our number smaller fraction is suppose k plus 2, right? So our fractions should be smaller, so that's time I will left will be still on the 0 and right will be 0.65, because I have to like maximum fraction are smaller than 0.65, maximum number of fractions. So if I tied it with minus point, suppose 0.4, that some it will happen that most will be discarded, right? So that's why I will decrease the fraction value limit. That's why our right pointer will shift to the mid. Okay, got it. And suppose our in another situation is like that, when our fraction value is k minus 2, our fraction value number of fraction value is smaller than our k. So this fraction value, there are not enough fraction whose value is less than equal to 0.75, 0.65. So I have to I have to increase the limit, fraction limit, right? That's how that will actually allocate more fraction into the range. That's time our left will be increased to 0.65 and right will be still 1. Got it, right? Two situation. Let's see the code, it will be more easy. Like left is 0 and right is 1. Why 0 and 1 I mentioned. Now suppose in binary search I calculated the mid value is suppose 0.5 here. Now I'll check how many numbers are smaller than um, 0.6, 0.5. Okay, so maximum fraction is 0 initially and total smaller fraction is 0 initially, and numerator index 0, denominator index is 0, and j is equal to 0. Why j is equal to 0? Because our like those fractions will always start from array of 0 with array of 1, array of 0 by array of 1, right? So that's why I started from numerator as j is equal to 1 always. Now our denominator is numerator is starting from I is equal to 0. Yeah. What is the range? I is equal to 0 to I less than n minus 1. Why n minus 1? Because in the last index I can't take any new element in the as a denominator, right? Because there is no element on the right side of the last element. That's why our range is I is equal to 0 to I less than n minus 1. Got it? And I will check that till which our fraction value is greater than the limit, current limit. So if I do array of I by array of j is greater than mid, okay, so I can, its equivalent is like if I multiply with array of j both, so this side also I will multiply the array of j, so array of j it will cut, so array of I will be greater than mid of array of j. So that's why here I have done this like j less than n and array of I greater than equals to mid into array of j. Similar like till the fraction value is greater than mid, that time I will shift till the fraction value is less than, we are not getting fraction value is not smaller than mid. So j plus plus, okay, I will shifted the denominator from left to right. Okay, so now j will point to like somewhere like 1 2 3 4 5. So j first pointing here, suppose 1 by 4, like we are getting this 1 by 4. Okay, so like 1 by 5 also will be less than the mid. Why? Because like 1 by 4 value is 0.25 and 1 by 5 is 0.2. So you can see like the denominator is increasing and numerator is fixed. Numerator both are fixed, 1 by x, 1 by y. If y greater than x, so obviously 1 by y will be less than 1 by x. Got it right? You know, right? 1 by x and 1 by y. Okay, if x or if x less than y, okay, that time our 1 by x will be greater than 1 by y, because we are dividing the 1 by with max greater value. That time we will get the minimum value, right? So I will I will take all the elements on the right side remaining. So how many elements? N minus j. J is pointing, and till the we will take as an fraction whose value is less than mid. So total fraction count will be increased by n minus j. And if n is equal to j, already like suppose 1 by 5 here we have taken, suppose 1 by 5, it's not still, it's still greater than mid, so we can't go right. So okay, so still 2 by 5 will be less than mid. Not possible. Why? Because 1 by 5 is not possible. Then if I increase the numerator, so how it's possible to decrease the value, right? So that's why I will break from there. Like if j is equal to n, I will break, and else it's um, not existed all the array. So I will check the fraction value. What is the fraction value? Currently a or array of I by array of j. Now I will check if this fraction value is greater than maximum fraction. Then I will store the numerator index and denominator index and also the maximum fraction value. Okay. And else after all the calculation, I will check if total smaller fraction is equal to k. Then that this is our answer, numerator and denominator. So that time I will answer the numerator index and the denominator index value. Else if suppose number of smaller fraction is greater than k, that time I have to tight the limit, I have to decrease the limit. That's why I will shift the right to mid. Got it? And if suppose our number of smaller fraction is smaller than this, that time I have to increase the limit. That will actually allow more fraction to add into the range, right? That's why that time I will increase the left pointer to the mid, right? Got it? And else in this way I will this binary search will work, and else at the end return null. This is the default case. Okay, got it right? Thank you.